Welcome to S&D Engineering and Research Center online lecture series. In previous lecture we have seen what is fuels. Today's topic is coal. Coal is a highly carbonaceous matter formed from vegetable matter buried in geomorphic changes under pressure by the action of aerobic and anaerobic bacteria for a long time. The time for transformation wood to coal depends upon the depth of the burial. The process of conversion of wood into coal is known as coalification. In general, coal contain mainly carbon atoms with mostly sp2 hybridization. Atoms like oxygen, hydrogen, sulfur, nitrogen are conveniently bonded to carbon atoms. Coal molecules are huge with identification number of carbon atoms. Coal also contain water and mineral particles entrapped. When coal starts burning, some of the heat produced is utilized to evaporate water and the minerals are left behind as ash. Burning coal in the absence of excess air or at low temperature due to thermal decomposition of coal molecules forms volatile matter and soot. Some of the heat during combustion under such condition can cause decomposition of the coal molecule to form a soot particle and volatile matter. The volatile matter is the unburned, decomposed coal molecule, fragments of colloidal size. Next, types of coals. Coals are divided into four types: peat, lignite, bituminous coals, anthracite coals. During the progressive from peat to anthracite, there is increase in carbon percentage, calorific value, density, luster, hardness, black color intensity. Decrease in moisture, volatile matter, percentage of nitrogen, hydrogen, oxygen, sulfur and ash. First, peat. Peat is brown and fibrous in texture. Freshly mined out, peat contains large quantity of water as it is found in waterlogged areas. Air-dried peat contains 15 to 25% moisture and it crumbles into powder during air drying. Calorific values of peat is about 5400 kg calorie per gram. It has low density. It contains 57% carbon, 6% hydrogen, 35% oxygen, 3 to 6% ash. Uses of peat. Peat type of coal gets powder during combustion, therefore it is used after benefiting as domestic and industrial fuel. It is used for soil conditioning. It can be used for steam rising, thermal insulation, packing, gas purification and some types of power generation. Second type, lignite. It is intermediate stage between peat and black coal. It is brownish black and more compact than a part. It contains 45 to 50% volatile metal and burns with long flame. Its calorific value is 6000 to 6700 calorie per gram and carbon percentage is equal to 65 to 70%. It contains 5% hydrogen, 20% oxygen, 10 to 15% ash. Uses of lignite. After briquetting, it is used as a domestic and industrial fuel. Lignite is used for making producer gas. It can be used for power generation. On combustion, it gives tar, which is used for making road and recovering various aromatic chemicals. Next, bituminous coals. These coals burn with smoky yellow flame are dark grey to black. They contain 70 to 90% carbon and therefore they are further classified: subbituminous coal, bituminous coal and semi-bituminous coal. First, subbituminous coal. This coal has characters between lignite and bituminous coal. Its calorific value is about 7000 calorie per gram and 70 to 75% carbon. It contains large volatile matter 35 to 40%. It crumbles into pieces on air drying during transportation. It is non-cracking coal. This coal is used for domestic and industrial purposes. Next, bituminous coal. This coal has blended or laminated structure with alternate bright and dull layers. It has crucible fracture. It is black, dense and hard. It contains 75 to 85% carbon and has calorific value 8000 to 8500 calorie per gram. It has cracking coal from coke and coal gas on carbonization as it contains 20 to 30% of volatile matter. Uses of bituminous coal. For making metallurgical coke and coal gas as a source of various aromatic chemicals. It is used most widely for domestic and industrial purposes. It is used for steam generation and power generation. Next, subbituminous coal. It has characters between bituminous and anthracite coals. It has low volatile matter and has cooking property. Its calorific value is about 8400 calorie per gram. Carbon percentage is equal to 85 to 90%. Uses of semi-bituminous coal. Making of coke, high temperature heating, coal gas for tar and chemicals. Next, anthracite coal. It has CV about 8700 calorie per gram and 92 to 98% of coal. It contains very low ash moisture, volatile matter ash moisture. It has highly lustrous black and hard coal. It shows colloidal fracture. It burns with non-smoky short blue flame of high temperature. Uses. Being costly coal, it is used for specific industrial purposes. It is used as metallurgical fuel. It is used for making electrodes. It is used for high temperature heating. Next, analysis of coal. The purpose for coal analysis are to decide price of coal, to determine quality, to specify use for a particular purpose, to calculate theoretical calorific value of coal, to calculate air requirement for complete combustion of coal, and design the furnace firebox suitably. Next, proximate analysis of coal. Proximate analysis is a study or analysis of coal sample in which moisture percentage, volatile matter percentage, ash percentage, and fixed carbon. First, moisture percentage. Principle of moisture percentage. All moisture in coal escapes on heating coal at 110 degrees Celsius for 1 hour. Method. A known weight of powder and air dried coal sample is taken in a crucible and it is placed in an oven for 1 hour at 110 degrees Celsius. Then the coal is cooled in a desiccator and weighed up. If the initial weight of coal is meter gram and final weight is grams, the loss in a weight corresponds to moisture in coal. Formula. Moisture is equal to loss in weight upon weight of coal sample into m minus m1 and m divided by m into 100. Volatile matter principle. At 925 degrees Celsius, coal molecules undergo thermal degradation to produce volatile matter. Method. Moisture-free coal left in the crucible in first experiment is covered with a lid loosely. Then it is heated at 925 degrees Celsius in a muffled furnace. For 7 minutes, the crucible is taken out and cooled in desiccators. When it is weighed, the loss in weight is due to loss of volatile matter in the meter grams of the coal sample. Formula. Volatile matter percentage. Weight of volatile matter divided by weight of air dried coal into 100 is equal to m1 minus m2 divided by m into 100. The volatile matter percentage can also be determined by taking the fresh weight of the air dried coal, but loss in weight at 925 degrees Celsius will be due to loss of moisture and volatile matter if W is the weight of dried coal and W1 is the mass of coal left at 925 degrees Celsius heating. Then volatile matter percentage, loss in weight due to moisture and volatile matter into 100 divided by weight of coal sample minus moisture percentage.